So if you are an operations manager, a training director, or frankly, just someone who relies on critical infrastructure, you know the core problem we're diving into today. You invest a fortune in training, in certifications, compliance programs, all of it, and yet there's still this huge chasm between training someone and having real objective proof that they can do a job correctly.
Every single time.
Every single time.
It's the ultimate operational blind spot. I mean, we spend millions optimizing the equipment, the supply chain, the software. But when it comes to the human element...
The person actually turning the wrench.
Exactly. The person turning the wrench. Our verification methods are, well, they're stuck in the era of clipboards and just subjective judgment. And that inefficiency, it translates directly into risk. Huge risk.
Okay, so that's our mission in this deep dive.
Yeah.
We're going to unpack the source material we have on a system called EON Assist IQ. It's an AI-native system designed to tackle this head-on.
Right. Focusing on objective skills assessment, operational readiness, that kind of thing.
We're going to look at how this technology is trying to fundamentally transform competence verification. You know, moving it from just watching someone to having machine-verified objective intelligence.
It's a fundamental shift. We're dissecting the evidence that suggests this replaces the old question, did they finish the training module?
Right.
With the only question that matters, did they perform the safety procedure flawlessly?
Okay, so let's start with the scale of this problem, this global crisis of skills verification, because the sources we looked at, they paint a really vivid picture of the stakes here.
It's a crisis because of that irony you mentioned. You know, we have these fully digitized systems, digital twins, predictive maintenance, sensors on everything, all optimizing the machine. But the methods for verifying the human performance, they're still analog, inconsistent, and, you know, totally rooted in checklists and just hoping the person signs off correctly.
It's the weak link in the chain. I mean, the system can be 99.99% efficient, but if the human performing the last critical step is only verified to, what, maybe a 70% standard of consistency, the whole system's exposed.
And that exposure is so costly. The source material is really clear on this. Human error accounts for the majority of industrial incidents.
Can you give us an example?
Sure. Think about a field tech doing a high-pressure pump shutdown. If they skip the step of, say, verifying the pressure gauge, or they turn a valve in the wrong sequence, that tiny deviation can cascade into an explosion.
Or a massive outage.
Or a full facility shutdown. And these critical steps are missed all the time, simply because the human assessor on a Tuesday might have a slightly different standard than the assessor on a Friday at a different site.
And when the auditors show up, what do they see?
They see attestations, a checked box. Someone said the step was done, but there's no defensible video-verified evidence. And that lack of proof is just crippling when regulators are raising the bar on accountability.
Which leads to the scaling problem, right? The bottleneck.
A huge bottleneck. A global company might have, say, 10 people in the world who truly know the right way to do a high-stakes task. They're the only ones who can assess others. They can't be on 5 continents at once.
And then they retire.
And they take that unwritten knowledge, that tacit knowledge with them, the stuff that was never in the 100-page manual but is critical to doing the job safely.
Right.
So the sources really drive this home. The core issue isn't a lack of training. It's a lack of reliable verification. You just can't prove the procedure was followed exactly as required.
Okay, so if verification is the problem, then the solution has to be an objective verifier. Let's shift to EON Assist IQ. How does this AI platform turn messy physical actions into structured, defensible proof?
Well, it's really focused on solving that single mission-critical question. Was this task performed correctly, safely, and according to the gold standard?
The gold standard principle. Tell us about that, because the sources describe it almost like you're cloning your best expert with AI.
That's a great way to put it. The whole idea is to capture a single perfect execution by your best subject matter expert. You know, the person who does it right every single time.
So you just video them doing the task.
You video them, and that performance is converted into a verifiable, machine-readable standard. This gold standard is then applied through Vision AI across, well, unlimited assessments. So the whole organization moves from assumed competence, which is super risky,
to provable readiness.
to provable readiness, exactly.
But hold on, doesn't capturing one single execution as the gold standard make things too rigid?
Okay.
I mean, operations aren't always identical. Sometimes you have to adapt a little.
That's a critical question, and the system has to account for that. The key is that the gold standard isn't just a rigid video playback. It's more of a spatial and procedural map.
What do you mean by that?
The AI identifies the critical actions, but also the acceptable zones for deviation. So if the standard says check pressure gauge A, the AI can be trained to recognize that action on gauge A, B, or C, as long as the operator follows the correct steps in sequence. It defines the parameters of correct performance.
Okay, that makes sense. So it's the what and when with some flexibility on the where. And this is totally different from, say, a learning management system or an LMS.
Oh, vital distinction. An LMS is about input. Did you click the link? Did you pass the quiz? It tracks completion.
Attendance, basically.
Right. EON Assist IQ validates real physical performance. It's validating the output, not the theoretical knowledge that went in.
Okay, this is where it gets really tangible. Let's get into the how. How does this platform go from a video of a technician to a mathematically defensible score? The sources talk about a 3-engine process.
Right. So the first one is the gold standard engine. Its job is to formalize all that tacit knowledge we talked about.
So it's not just watching, it's observing.
It's observing. It uses advanced computer vision, object detection, human pose estimation to map the expert's execution. It tracks tools, hand placement, dial movements, the timing of every step.
So it's breaking down that fluid human motion into structured data points.
Precisely. It structures and timestamps every single step. And critically, it also classifies the criticality of that action. Is this a safety critical lockout step, or is it a minor prep step?
So it converts that unwritten expertise into, what do the sources call it?
Enforceable operational truth. It's the objective, codified definition of what correct actually looks like.
So once you have that gold standard, the second engine, the AI assessment engine, comes in. How does that handle mass evaluation?
Well, that's the beauty of it, the scale and the consistency. Every trainee's performance recorded on video is evaluated step by step against that single machine-readable gold standard.
And it just looks for differences.
It automatically detects deviations. Did the trainee miss step 4? Did they do step 7 before step 6? Did they only turn the emergency valve halfway?
So it eliminates the human assessor's fatigue or their bias or just, having a bad day.
Exactly. And it flags all violations and classifies the severity instantly. This is how you break that scaling bottleneck. The AI can assess thousands of performances, freeing up the human experts to actually coach people.
Which brings us to the third engine, quantified, risk-aligned scoring. How does it turn those deviations into a score that a manager can actually trust?
This is where the risk alignment is key. Not all errors are equal, right? A missed housekeeping step might dock you a point. But if the system detects a critical safety failure like failing to lock out a machine that's weighted so heavily, it triggers an automatic fail.
Regardless of the overall score.
Regardless of anything else. The scoring is tied directly to the real-world consequences of failure.
So it's all about operational risk, not just a simple percentage.
It creates these really clear results: pass, fail, or needs review. But, and this is crucial, the machine can't have the final say.
Ah, okay. The human governance part. It's human in the loop. So how does that stop the AI from just being a black box you can't argue with?
The AI gives you the scale, the consistency, a detailed recommendation, but the supervisor keeps the final authority.
So they can review the AI's decision.
They can review the precise video evidence, the time-stamped, highlighted mistakes, and make the final call. But if they choose to override the AI's recommendation, say from a fail to a pass,
You have to justify it.
they have to provide documented justification.
That's a genius mechanism. It makes the human accountable too. Every decision, machine or person, is traceable and auditable.
It creates that immutable audit record that regulators demand while still ensuring there's fairness and human oversight.
This brings us to the structural shift this enables. When we look at the before versus after of implementing this, the contrast is it's about a complete change in operational certainty, isn't it?
The contrast is stark. Before, you have manual observation. Inconsistent standards. Houston's assessment is different from Singapore's. It's always one-to-one, tying up your best people.
And compliance is based entirely on assertion. Someone just checked a box.
And now, the after.
After, you have AI-verified execution against a global gold standard. Consistent enforcement everywhere. Immutable, evidence-based records. Compliance is no longer an assertion. It's proven through data.
And the sources kept emphasizing that the system is AI native. What does that mean exactly?
It means it's not just some machine learning feature bolted onto an old checklist system. The entire architecture is built around this kind of objective assessment from the ground up.
And that's what unlocks the big advantage.
Infinite scale from one expert. That one perfect execution, codified once, becomes the benchmark for a global workforce of tens of thousands. It solves the talent drain and the scaling problem at the same time.
So who needs this level of objective proof? Where is this making the biggest impact?
Well, really any sector where error is catastrophic. Industrial manufacturing for sure. Energy and utilities, think nuclear plant maintenance or pipeline repairs. A misstep there could be a national incident. Healthcare too, I imagine.
Oh, absolutely. Healthcare and life sciences, sterile environments, complex diagnostic procedures. Basically, if you're in a regulated environment where human failure is high cost or high risk, this is essential.
So beyond the immediate wins, like faster training and fewer incidents, what's the long-term strategic asset this creates?
It's the data. Over time, it's all about the continuous skills intelligence. At first, you use it to certify people. But once you have thousands of objective data points on performance,
You start to see patterns.
you see patterns of systemic risk. The assessment data becomes this incredible strategic asset.
Give me an example of an aha moment that data might provide.
Okay, imagine the data shows that 90% of your new hires at Site C and Site E are consistently missing Step 4, the torque calibration check. But the train-ins at Site A never miss it.
Right.
That's not a personnel problem. That's a systemic training failure or a problem with the procedure document specific to those two sites. The AI data pinpoints exactly where you need to fix your training or your process before it leads to an incident.
So it shifts risk management from being reactive, waiting for an accident, to being proactive and based on real-time data. That's a huge shift.
It's the end of that episodic once-a-year evaluation. It's replaced with continuous objective validation. It finally closes that gap between what's in the training manual and what's actually happening on the ground.
So this objective validation is fundamentally shifting how organizations view their people and their risk.
I mean, ultimately, the shift is about recognizing that just relying on trust and subjective observation for critical tasks, it's just not tenable anymore. Data has to replace assumption.
And that brings us to our final thought for you, our listener, to consider as you wrap up this deep dive with us.
If AI can perfectly codify and consistently assess the gold standard of a procedure, the perfect repeatable performance of a task, what does that actually mean for the human expert? It raises a really fundamental question about the value of a human worker. If the machine handles flawless execution and verification, does the value of the human shift entirely to complex problem-solving, creativity, and adapting to all the non-standard scenarios the AI has never seen before? It's something to think about as these systems become the new foundation of operational readiness.